Okay, this video is about the IQR, or the interquartile range. We talked about the interquartile range in the last class, where we were finding the quartiles, and we knew that the interquartile range is found by taking the difference of quartile 3 and quartile 1. So the IQR is found by doing quartile 3 minus quartile 1. And so when you have found your quartile values, you can easily compute your interquartile range. Now this is a measurement that indicates the spread of the middle 50% of your data. Another item that the IQR is used for, and we looked at that with our last lesson, is that the IQR does help us to find if we have outliers. And we do that by multiplying 1.5 times the IQR. And that gives us a value that we then add or subtract to quartile 3 and quartile 1. And this gives us our upper and lower fences. And anything beyond those upper and lower fences would be an outlier. And so we worked on that, and you have some examples in our last lesson on how to do that and how to figure out whether things are outliers or not. Some advantages of computing an IQR is that it's another pretty easy calculation. Not quite as easy as the range because it does involve finding each of the quartiles. But it would be easy if you already have your 5-number summary. A disadvantage of this particular measurement is that it only deals with your middle data set. Then when we find the outliers, it does help us to find extreme values, but that would be on the ends, but the main thing that the IQR does tell us, of course, is the fact that we have the spread of the middle. So let's look at an example again. If we had the 5-number summary for a set of data that was 5, 8, 10, 12, and 20, and in that order we would have the min, quartile 1, quartile 2, quartile 3, and the max. So to find the IQR, it would be quartile 3, which is 12, minus quartile 1, which is 8, and that gives us an IQR of 4. And then if we were trying to find out if we had any outliers, then we would take this IQR value and multiply it by 1.5, which means that would give us 6, and we add that to the upper quartile, so 12 plus 6 would be 18, and we subtract it from quartile 1, so 8 minus 6 would be 2, and these are our fences. So our upper fence is 18, our lower fence is 2, and we would look at our data set to see if we have any extreme values. Now our maximum value is 20, so that is beyond our upper fence, so that max value would be an extreme value. On the lower side, with 2 being the lower fence, our smallest value is 5, so we would not have an extreme value on that lower side.